understand that we may have a problem here. So to counteract that, what people do is they create centered variables. They literally subtract the mean from each of the independent variables, and then they multiply those residuals together to create a centered product term. So the fastest way to do this, I mean, what you can do is you can calculate a mean in descriptive or frequency statistics, and then do some transformation, do a compute statement and transform. But I'm going to actually do it more quickly by going aggregate. This is a little trick if you don't know about it. I'll go into hassles, and it's going to create a mean variable for hassles just automatically. So the mean for hassles is 170.20, and in fact, if you look at the decimal place, it actually goes further than that. It goes to it's 1.964, and that's what actually David C. Howell reports in his textbook. So if I want to create a centered variable from that, I just have to create it. So I'm going to subtract hassles from this hassles mean variable that I just created through the aggregate. And so here's my centered variable here. So 16 minus the mean of 170 is negative 154. So that's my centered variable. Now I don't need this variable anymore. And now I'm going to create my support centered variable. I'm going to use the same little aggregate trick in SPSS. And then transform, compute. Support centered. So my support variable minus that support mean variable I just created. Oops. All right. So that's created two variables for me, two centered variables, support centered variable and a hassle centered variable. And now I'm going to create a product term out of those centered variables to represent the interaction effect. So hassles support centered and hassles centered multiplied by support centered. Alright, so here's my product term now. And I could look at the correlations again to see if there's any change in the magnitude of the multicollinearity, and it should reduce. So now we have a correlation between hassles, even though I won't be using that variable in the multiple regression, although maybe you could, but it's reduced down to negative 0.297. And if we look at hassle-centered, it's the same correlation because I'm only subtracting the mean effect off every single score in the variable. So it's one step towards a z-score, if you will. But it's not a z-score, it's really just a centered score. So this has reduced the correlation from 0.835 down to negative 0.297. So now we don't have a problem with multicollinearity, arguably. And I'll mention now that centering variables is even something controversial, even though you see it very, very frequently. And I'm just pretending like that's your only option. The truth is that maybe you don't have to center variables. Maybe it's not as big a problem. And I'll do a separate video on that. And there could be some benefits to not centering data. Anyway, I won't go too far into that, but it's an interesting topic. Okay, so now that we've got our hassle-centered variable, our support-centered variable, and our hassle-centered support variable, now we can test our interaction hypothesis. And we just have to perform a regular multiple regression. And so we can go into linear. Now I prefer to do it in a hierarchical multiple regression stage. I won't do it that way right now. I'm just going to put symptoms into the dependent variable, because that's what I'm trying to predict, and I'm going to put hassle support and hassle support centered into the independent box. Alright, and the hypothesis is that this interaction term, hassle support centered, is actually going to be a statistically significant predictor of symptoms above and beyond the hassle centered and support centered variables. Alright, so let's check with the results. We get a multiple R of 0.623, R squared of 0.388. Adjusted, it's 0.35, so we've got 35% of the variance in symptoms being accounted for by this multiple regression model.